Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to today's webinar, Process Safety Management in Water Utilities. My name is Megan Purdy and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them and their cultures and to elders past and present. Before we get started, I would like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, Urban Utilities. Urban Utilities is a leading provider of world-class drinking water and wastewater services covering the communities of Brisbane, Ipswich, Lockyer Valley, Somerset and the Scenic Rim. They are one of the largest water distributor retailers in Australia, supplying drinking water, recycled water, and sewage services to a population of more than 1.5 million in southeast Queensland. Now, today, we'll hear from our speaker, followed by our live audience Q&A. So I encourage you all to please send your questions through to our speaker via the chat box. So I'd like to welcome our speaker, Jamie Barnes, Principal Process Safety Engineer from Urban Utilities. Jamie's responsibilities include supporting the development and implementation of strategic and tactical initiatives to manage process safety risk and facilitating safety assessments. Jamie has been active in defining and supporting an appropriate approach for process safety management within urban utilities. Please join me in welcoming Jamie Barnes.
Thank you for the introduction. So for today's presentation, I'll obviously start just with the agenda. So I want to talk about defining process safety and what it is, both in the context of hazardous industries and also water and water utilities. Look at the context and application of process safety in water utilities specifically and how that might apply. Then I want to talk about a risk-based approach for existing operations and some practical understanding and some practical application as to how that can be done and applied. And then finally, I want to talk with the link that this has to management systems within the business. So there can be an understanding around how to integrate some of this work and make it useful in that sense. So I think the first thing that should be discussed, especially in the context of the water industry, is what process safety is and what it isn't. And I think this discussion is quite important in the water industry because it mightn't be something that's as familiar as, say, in hydrocarbons and mining. But this really powerful, simple slide talks about the difference there. So with respect to personal safety, people associate that typically with slips, trips and falls. Whereas process safety is quite different. It's usually failure of assets or failure of infrastructure or engineering controls that cause harm. So from that small analogy with the stairs, you can see that the failure of the stairs has a very different mechanism and characteristic than, say, a fall on a stairs. The other thing that the diagram helps call out is if there's a dozen people on a set of stairs and it fails, then a dozen are injured and potentially fatally injured. Whereas it's very unlikely to have a dozen people injured at the same time from an occupational health and safety event on a set of stairs. There's another few differences. So with personal safety, you tend to encounter the hazard, meaning you go to it through work. Whereas in process safety, the hazard tends to find you. So one of the most dangerous things about process safety events and incidents is that they're unexpected and they're often sudden, and the hazard the controls fail, assets generally fail, and the hazard comes out from containment and it finds you. And it's typically referred to as a loss of containment event. Just on the right, the slide there shows that there is an overlap between the two types. Now, as the frequency reduces and the consequence goes up, we're typically describing process safety incidents and process safety events. So very low frequency, very high consequence type events. Very different to occupational health and safety, where there's a high frequency generally and a low, sometimes they can be fatal too, but for the most part, low consequence events. So quite different. So with that in mind, I think it's also important to talk about the definition of what process safety is, and especially in the context of water. So there are a lot of definitions for process safety, and the term process safety management can have certain connotations in certain jurisdictions. legally. But in terms of, I thought it wouldn't be useful today to talk about all the different definitions, but just give a brief description of the essence of what they all sort of say. And so process safety really is around the systematic approach for managing the integrity of processes. Now, traditionally, that's with hazardous chemicals, but what I want to talk about today is processes with hazardous consequences. And whilst that's only a small difference, I think it makes a large difference in the overall scale and impact of the management. And as we talk about the hazards that are present in this industry, I think that will make more sense. So for an incident, in the context of this discussion, we're talking about an uncontrolled release of a hazard, a process safety hazard, or the loss of control of that hazard with hazardous consequences, and generally with a serious and immediate risk to human health and environment. So that may occur as a loss of containment, meaning that there's a primary containment failure and a chemical or a hazard is released, or it could be through a loss of control, like a functional failure or a secondary failure that then cascades and causes a primary failure. Now, with this consequences, typically we're talking about safety consequences, though there are other consequences that can occur. And it's an important discussion to have within your organization around what level of consequence. But for the purposes of this discussion, and I think for the water industry, it's really around fatal incidents to one or more persons, and they may occur or turn up as, say, fires, explosions, toxic releases, etc. Now, one thing I just want to draw attention to is that in the water industry, we obviously supply water, drinking water to large populations, and there's something to discuss or to think about whether or not water safety and process safety have overlap. Now, generally, water quality is managed through drinking water quality management systems, and usually those systems are done quite well and they're quite robust. But it's just worth pondering that water isn't necessarily hazardous, but failing to manage a water supply system has hazardous consequences. So under that definition that I talked about earlier around processes with hazardous consequences, depending on the scope and the nature of the definition, it could include water quality, and it might not necessarily have to replace it, but it can definitely support it and improve it in some aspects. So I want to touch on incidents and the concept of foreseeability. The image on the left, most people are probably familiar with, which is Buncefield, which was a fuel storage depot fire in 2005. The one on the right, some people may not have seen. It's a water transfer pump station in Abbotsford. This incident occurred in 1984. Now, to look at these visually, it would be quite easy to think that the one on the left was far more serious, and in some senses it could have been. But what's interesting is that the one on the right had 16 fatalities and the one on the left had 0. So the foreseeability aspect of incidents is an interesting thing to keep in mind as we move through this discussion around management, because you can't manage risks that you don't understand and you can't manage risks that you can't see. So it requires, risk management requires an inherent belief that risks are manageable and that hazards can be found. Otherwise, the entire system won't work. Now, on the right, with Abbotsford, that was a water transfer pump station where the pipe was offline for a period. A coal seam underneath that structure, which people hadn't identified in the design. Gas had come up through the ground and accumulated in the pipe. When the system was turned back on, that gas was pushed through the system to this endpoint here, where people were present, and unfortunately, members of the public were present too. And there was 8 fatalities immediately from the blast, and a further 8 in the 24 hours after that. And there was a long and lengthy legal battle around the foreseeability and the liability of this. I just think it's very important that we look at that and think about how foreseeable that is, and challenge ourselves around our traditional focus of what some of these incidents look like. So I want to move into more industry specific now and look at the factors and the processes that we have quite commonly within our industry. So in water treatment, scheduled chemicals are something that process safety management tends to focus on. So for any scheduled chemicals, which are generally referred to in the Workhouse Safety Regs and Workhouse Safety Acts, if you hold a certain quantity of scheduled chemicals, then you can become a major hazard facility. Now, a major hazard facility needs to submit a safety case to the regulator in order to get a license to operate. And I've just put up here that a couple of common scheduled chemicals that are present in water that can trigger that requirement are chlorine, ammonia, and also oxidizing agents such as ozone and oxygen. Now, they're usually quite high, and it's not very common to go over those thresholds. It is worth noting, though, that there's a 10% threshold notification. So for chlorine, it's only 2.5 tonne, where you would have to submit and notify and have an assessment done to see if that facility meets the requirements for a major hazard facility. And if it does, there's a need for a safety case. So in a traditional context, in a hydrocarbons context, major hazard facilities are very common, and they rely on the process safety approach for safety case management. In water, we've got a couple of chemicals that show up, and there are instances in Australia where certain water service providers have triggered MHF requirements for chlorine. It's usually chlorine that's quite common, and have needed to present a safety case for that. We look at the other part of the industry in terms of wastewater and sewage treatment. We may also have scheduled chemicals, just as we have on water treatment sites, because we often have effluent treatment as we do in water treatment. But there's a bit of a difference emerging in terms of the hazards due to the nature of the operation. Now, wastewater and sewage treatment, depending on how solids are managed, tends to have a lot of process hazards emerged in the biosolids management space, and that's generally due to anaerobic digestion. But then when anaerobic digestion is present and biogas is present, a whole host of other processes are generally coupled and brought in order to make the facility more efficient and more productive. I just want to show this is one of the facilities that we have at Urban Utilities that's been under an extensive process safety review for a number of years. We have a whole host of different hazards that emanate from the facility, and it's important to note that technology will generally drive the risk here, and methane is a scheduled chemical at 200 tonnes, but you need to hold a hell of a lot of it to actually trigger that, even 20 tonnes at the 10% threshold. Even with biogas storage, it's probably not that common. But that aside, it's about the risk. And some of these facilities become very dense, small footprint, high hazard, or lots of hazards in a small area, which makes the risk higher. So it's worth reflecting. We just talked about water, which generally has scheduled chemicals. Wastewater can have scheduled chemicals too. But in wastewater treatment, we see process hazards emerge depending on the technology and the type of processing being done, which can have fatal consequences. And back to our definition around process safety and having hazardous consequences that are fatal, we're starting to see that these processes qualify for process safety management, whether or not they are scheduled chemicals or there's a major hazard facility requirement or not. It's driven by the definition, essentially. So just to sort of bring that together and summarize, it really isn't about hazardous chemicals, or not just about hazardous chemicals. The processes that we operate, depending on the technology and the type of sites that we have, are inherently hazardous. And we're seeing that solids and sludge management processing hazards tend to dominate in that they become like a small hydrocarbon plant. Depending on the scale, we've got steam boilers, thermal processing, cogeneration often in gensets that are coupled up to biogas, and flares as well. So if we bring this picture together on a large wastewater or sewage treatment plant, we can have all of these hazards without the need for a safety case. And they can each be fatal and have significant effects both on-site and in some cases off-site. So it's just worth noting that there's a distinct difference between the hazardous chemicals and the physical process hazards, and they can be present together at that level of risk that's fatal. just want to draw an analogy. So water and power can be synonymous in the sense that both can have physical process hazards and not chemical hazards, and yet they can have fatal risk. So for those who may recall the C4 failure at CS Energy, that wasn't about hazardous chemicals. That was very much around engineering controls and physical plant. And in the review for that, some of the failure has been attributed to shortfalls in understanding hazards and managing risk, which is an important part of process safety management. And as we look at our facilities and how they approximate this type of infrastructure, we can see that we are getting closer, maybe not on the same scale, but we're getting closer in terms of the type of hazards and the type of risk that comes with, say, power generation or power plants. So really, scheduled chemicals are only part of the fatal hazards present on a site like a sludge processing site. And we need to understand what the hazards are and understand exactly what risk they present. And just with the word cloud down the bottom, I've got a whole host of different hazards there that can be present at a wastewater or sewage treatment site that goes beyond the typical hazardous chemical approach or definition. So that's worth considering. As things evolve, we will find that hazards tend to intensify. Now, depending on the future of processing, in particular biosolids management, we've gone from conventional processing through to advanced waste to energy processing, things like sludge incineration, pyrolysis, and carbonization. As we move more towards renewables, this tends to increase. And an important consideration with process safety management through hierarchy of controls is, can these things be eliminated? And generally no. So we're going to have really strong and robust engineering controls through safe design, inherently safe design, good operations and maintenance practices that take us into the future to help us manage these hazards as we tend to shift, as the industry shifts towards this type of technology. So with that, I just want to touch on what can be done or what to do and approach in terms of, we've just discussed the hazards that are present within the industry. Also in the context of, generally there isn't a need for a safety case because the quantities or the types of hazards don't trigger that major hazard facility requirement. So in terms of, I want to introduce the Center for Chemical Process Safety risk-based approach, and they have a really excellent risk-based process safety guideline that's available. And the CCPS put this quite simply. They put forward, ask yourself 3 questions. So in terms of your risk, what can go wrong? How bad could it be? And how often might it happen? Now, really what those 3 questions are formulating is they're calling for the need to perform a process safety risk assessment. And that process safety risk assessment, in the context of the larger framework that the CCPS offers, is really the basis or the fundamental starting point for management. So on the right, I've got the process safety management system framework as per CCPS. It's made up of 20 elements, 4 pillars. And you can see that I've circled out here in the understand hazard and risk pillar. We have a couple of elements there that are really around process hazard analysis and understanding hazards and assessing and analyzing them. And then on the right, with the manage risk elements, that's really about focusing on what matters and managing your risk accordingly based upon your assessment. So I want to talk more about this overall context, bring a few concepts into the picture, and then return back to this and talk about how it assists with the management approach itself. So in terms of a risk-based approach, a place to start, as I mentioned in the framework, is understanding hazards and analysing hazards and assessing risk. And the question is, how do we get to what's important from understanding that? Now, there's people that are familiar with process safety will know what a process safety incident bow tie is. But I think it's really important that we just stop and ask, well, how do we develop a bow tie and what goes into it? So from that process hazard analysis point of view, back in the management space, you really can't manage risks that you don't understand. So it's really important that you actually go and identify the hazards first and look at how they um, relate to your organization and how they present in your operations. Now, in a greenfield or a brownfield context, this approach is equally valid, but I want to talk about more today around brownfields and existing operations and how that can be applied. So a hazard ID, which most people will be familiar with, a hazard identification study, typically looks at external factors, interactions between plant, and pulls out hazards that are present on the site and puts to the forefront things that could be fatal. Now, in a hazard ID, not everything's going to have that high level of risk, but you can screen through hazard ID and work out what does. Similar for HAZOP. For HAZOP, we're talking about internal process factors. So in a HAZOP, there's a deviation from the process intent and then there's an effect. And in the HAZOP, we can quickly determine what relationships exist to cause those things to happen. From those two pieces of work, we can screen them and develop incident scenarios. Now, when screening, it's important to look at what's credible, look at what's fatal and significant in terms of its consequences, and then try and characterize these into process safety incidents like loss of containment or loss of control. Once that's sort of characterized up, you can then go and build an incident bow tie that's essentially a visual HAZOP and represents the incident with the controls, causes, and the consequences. Now, introducing this concept I think is important because I want to talk in a little bit more detail about how the bow tie actually works and how it's developed from these studies. You don't have to go through hazard E, hazard to bow tie. They can be done other ways, but I think in terms of a structured approach, this is quite helpful and quite useful as a tool. So continuing on with bow ties, I mentioned that essentially they're a visual incident or a visual HAZOP. So the HAZOP's really good at identifying the cause and the barrier synonymous with the word control, both prevent and mitigate. And also the hazard D is very good at identifying the hazard, the top event in the center, which is the point at time in which you've lost control over the hazard. It's the characterization of the incident, i.e. loss of containment or loss of control. And then on the far right of the bow tie diagram, we've got the consequence. So just spending a little bit of time on this quickly. The Swiss cheese model by James Reason is heavily connected to bow ties in process safety management. So it's important to understand that all barriers on a bow tie are not perfect. All barriers have holes. And some of those holes or weaknesses are inherent at the time of design, and some of them degrade over time, meaning that what we do day in, day out, how we operate our facilities and maintain them, has a large influence on the integrity of our controls. So we need to manage them appropriately. We need to manage change to them, and we need to make sure they remain effective through their life cycle to keep the risk controlled. So looking at the bow tie, I could probably spend an hour talking about how bow ties work, but I think it's important just to touch on this. Looking at the diagram read left to right, the cause is the deviation or the upset or the factor that drives the process safety incident. Now, with no barriers or controls on the page, the cause basically has to take you through to the center of the bow tie, which is the point at which you've lost control. Now, at that point, there hasn't necessarily been any consequences. There's still an opportunity to recover or to stop the escalation or the progression of the incident through the mitigation barriers. However, if the mitigation barriers fail and you move all the way to the right, you've got the full unmitigated consequences of the incident. An example could be overpressure on the cause. The barrier may be a pressure relief valve or pressure trip system. It may fail, take you through to a top event or in the center where you've lost containment of, say, gas. And there might be an opportunity then to have a mitigate barrier that actually shuts that system down and makes it safe. However, if that doesn't work and there's an ignition source, you could have, say, the full consequence, such as a fire or an explosion. So a really important concept to bring together, meaning the Swiss cheese model and the bow tie, which is pretty famous in process safety management, and really to keep in mind that not all barriers are perfect. They require a lot of work in order to obviously design them so they're inherently safe, but then maintain them over time so they remain safe. Another important point that I want to touch on to bring us right back to that management space and the framework is that the bow tie as a visual incident really lays out the incident as a diagram so you can see what's happening. Now, the barriers on the page need to be managed to prevent and mitigate the effects of the incident. One of the things that's really important in your bow tie risk-based approach and the barrier management approach is the identification of critical barriers. So every barrier on the bow tie is important, but some are more important. Those more important barriers are typically termed critical barriers or critical controls. And critical controls or critical barriers have safety critical elements within them. So there needs to be a process undertaken at the point of bow tie development to identify what is critical. And there's a number of techniques that are available to do that. Once that's done, it's really about looking at those critical barriers more closely, defining how they perform through something like a performance standard or a control standard, and then going about really detailed barrier management to make sure that they're healthy and that they work to prevent incidents and mitigate the consequences of loss events and incidents that do occur. So that whole approach really is often termed as barrier management. And I think this risk-based approach through bow tie and critical control management is at the core of the process safety framework that CCPS offers. And it's really the starting point for process safety management because, as I mentioned earlier, you can't manage risk you don't understand, and you can't perform a risk assessment until you know what your hazards are. And that takes us into the next part of the discussion where I want to talk about how we can actually go around performing process hazard analysis on existing operations. So we think about the type of technology and the type of processes that we have in water. They're not all the same and they can be quite different. And I think if we're undertaking a PHA across the business, we need to understand the scale of the business, the process hazards, where they are, their consequences, and how they relate to the process safety definition that the business has accepted and set. So in a brownfield context, back to that analogy of really low frequency, high consequence process safety events, some of the operations will qualify to meet that criteria and some won't. So you may have simple pumping schemes shown at the bottom there where the majority of the hazard and HAZOP has identified personal safety or occupational health and safety injuries. That wouldn't necessarily qualify to go forward for bow tie assessment because it mightn't be deemed to be a credible process safety incident, depending on the criteria set. So there may be no loss of containment there that's fatal. So it might be screened out and managed through other processes. But as we move up the curve, we can see that we get into different operations with higher levels of hazards and more risk. And those operations are good candidates to go forward for bow tie and process safety critical control management. So in undertaking this and starting out, I think it's really important to acknowledge that not all operations have process safety hazards. And that's an important thing to communicate early on because it can be overwhelming to look across the entire business and think undertaking process safety management means I need to apply the same depth and rigor to everything everywhere. And through the flexibility of a risk-based approach as per the CCPS, it's really not the case. It's worth focusing on what matters and focusing on the controls that save lives in those operations to give us the most risk reduction where we need it. Now, an approach for this, as I mentioned, is hazard E, HAZOP to bow tie. So at a high level, what's really useful is to hazard E across your operations, across your asset base, and identify where those hazards and incident scenarios are and where they sit. And then if you've got existing HAZOP studies for facilities or for units, you can use them to pull out that information as well to help build your bow tie and screen your fatal events. After that, it's really just a matter of creating bow ties for credible process safety incidents that have that level of fatal risk depending on the nature of the operation and the hazard. Now, an important point is you are free to brainstorm and build bow ties. It's something that we've experimented with and it works quite well. So there's the degree of freedom in starting and having a brainstorming session and a hazard and building a bow tie in session and seeing what emerges and letting the creativity flow to have that come through. Uh, Very similar to a hazard. Looking at what if and brainstorming approaches is quite good and powerful too. And then we can use detailed studies like HAZOP and hazard that are structured to help us fill in site-specific and asset-specific controls on our bow tie. So we could have a digestion bow tie at a business level that's very generic. And then we could look at a HAZOP for a facility and say, well, these controls apply to that facility and fill it out based upon the information that we've already got. It's quite powerful. I think the key takeaway here is start with caution, recognize that not everything has the same risk, and focus where that risk is the highest. And in order to do that, you need to start with hazard analysis and probably look across the entire business. And inherently, a lot of people will know where this risk sits because they work with it every day. But through a structured process, you can definitely fill this picture out and move from there. So an example, back to the sludge facility that we looked at just briefly earlier, if all these hazards are present on the site, we can then build bow ties for each hazard at a site level and an asset and hazard level, specific level. So in the risk analysis and assessment space, I've shown 4 bow ties there. For example, say steam, biogas and electricity from cogeneration and H2S. Each bow tie has its hazard and its consequence. And from that identification at a facility level, you can pick those scenarios out, build the bow ties, and then move into a register, as I mentioned earlier, around critical controls, so safety critical elements. And you can start to get a picture of what's critical. For starters, what incidents do I have? What controls do I have? And then based upon critical control identification, what's really important to manage those hazards? And then from that, it allows you to move into the management of critical barriers, which is the most essential step in the risk management approach. At a business level, if you've got a number of sites that have process safety hazards, you may have a number of bow ties for each facility, and they can be rolled up into the site risk register, but also they can flow, that information can flow through to the site and the corporate level risk management processes. And that's an important piece around integration because some of these assessment techniques are quite specialized in terms of hazard and HAZOP. They're quite engineering focused and they're technical. And everything I've talked about to date has only been a qualitative assessment, a qualitative risk assessment. But in some cases where risk is found to be very high or there's a lot of uncertainty, there may be the need to quantify the risk further. So the value in the bow tie is that you can understand the incident and see essentially what's going on. And you may wish to work that up into a quantitative assessment and actually go through and quantify how many layers of protection do I have, what sort of reliability do all of these barriers have, and what risk target do I need to achieve for this facility. So bow ties are a great opener to move from qualitative to quantitative risk management. Not a focal point of the discussion today, but for anyone that's interested, I think it's worth looking at layer of protection analysis and how that fits in with bow ties and bow tie management and barrier management. I think from this slide at a business level, looking across, the story really emerges around what does a risk register for the business look like? And it's calling out the risks at a site level that are process safety related, driven from the hazards. It allows us to move into barrier management at a business level. It allows us to focus on our assets that are critical, our safety critical elements that are asset related, which are generally engineering controls. And then also look at our safety critical activities and our operations, which are generally admin or people related controls. So the asset management system and the health and safety management system play a really important role together in bringing process safety to fruition. And it's important to understand that in the context of the hazard assessment and the risk assessment, it's quite specialized, But when we get to management of barriers, it's generally relying on existing systems like the asset management system and the health and safety management system. And in some cases, once the bow tie is built, you can quite easily move off from that and look at your barriers and find evidence of where those barriers are already being managed in your operation. And in some cases, you might find gaps and have a lot of actions to go about closing those gaps so you can have more assurance around control effectiveness and how those controls are working to prevent incidents and mitigate consequences. And just on that, each barrier that's going to be managed needs a KPI, and that KPI is part of the assurance and the verification process. So in a business with a critical risk framework or a critical risk management process, this can be treated very similar. The process safety barrier management can be treated very similar. Admittedly, we're talking mostly about assets, but there are instances on bow ties where there's safety critical operations and safety critical activities that turn up time after time. They may be enterprise wide, whereas the assets are more site specific and asset specific. But it's important to note that if we're moving into barrier management and focusing on critical controls, we definitely need to ensure that we've got appropriate KPIs so we can have critical control management and look at that assurance and verification process. And just another thing I just want to touch on systems. So we just talked about the relationship between the health and safety management system and the asset management system for barrier management. But there's another piece just to bring together here. So ISO 31000, generally most businesses operate to that accepted risk management framework. The bow tie has a really important role and a unique role in process safety management to play to support the ISO 31000 approach. So looking at the 31000 flow, the risk assessment piece in the center really starts to relate to the bow tie. And you can see from this diagram that identification, analysis, and risk evaluation are all things that we've talked about in the context of hazard E, HAZOP, and bow tie. And they couple in directly with that part of the framework for those types of assessments and those types of hazards. So 31000 can be leveraged to support process safety management, providing the right tools, i.e. the bow tie, are brought in and used appropriately to do that. With the risk treatment aspect of 31000, it's important to look at the requirement to understand like how many controls are enough. And once a bow tie is visually laid out, that's an easy thing to understand, much easier to understand than having that in a spreadsheet. And the bow tie becomes a discussion point for talking about safety and risk investment decisions and also risk treatment plans. So under Work Health Safety Act, there's a requirement to eliminate risk or reduce risks of up. This tool and this framework gives us the basis to go ahead and do that and understand exactly what we're talking about when we're saying we need to add controls or change the way that we operate to control the risk. And on the right-hand side of the diagram, I just really want to call out that the monitoring and review part of the framework really calls for process safety lead and lag indicators and KPIs to be set and monitored, and that there is a system of work to monitor, measure, and learn from what's coming out of that, because you can't improve things that you're not actively measuring and monitoring. And the understanding that comes out of that, it's important that's carried through to monitoring and performance review. I just want to return back to the crux of the discussion, back with the CCPS framework, and bring it together. So I think an important point here is I've talked a lot about bow ties and hazard E and HAZOP, and the reason for that is because you can't manage risk you don't understand. So you need to start with the understanding of risk and the hazards. However, don't forget the rest of the framework. There is an entire framework here of 20 elements that make up a really, really useful management system in order to manage your risk appropriately. And it's very important to start fundamentally with understanding risk and focusing on what's critical, and then improving systems over time through the adoption of the principles through this framework. Now, there are a number of frameworks that can be used. This framework is quite useful, has a lot of flexibility. It's not the only one, and it may not fit your organization, it may not suit it, but it's quite useful and very practical with a lot of guidance material. A lot of companies may choose to roll out elements one at a time, or look strategically at what fits best and how you pull on parts of that management system to get the most bang for buck. So in terms of rolling out sequentially, as I mentioned before, most important thing is to understand your hazards and manage your risk. So it makes sense to start with risk assessments and hazard process hazard analysis to get that information and understand it. But the other parts that really bring this together are management of change, because over time, changes introduce risk. And if changes aren't managed, barriers degrade and risk increases. So management of change is a really key fundamental topic in process safety management that goes hand in hand with everything that's been talked about today. Competency in training is critical. We need people to understand hazards and operate safely. And that's in the operations and the maintenance space. And then another one, just measuring performance and responding to weak signals. Lead indicators are really valuable, and they can stem from barrier management in terms of critical control management and verification processes that can pick up things ahead of time before they fail and cause incidents. So the whole framework is very, very important. Whilst I've focused on just a small part of it, there's a reason for that because it's useful. But I think it's really important to bring together the picture here and look at the entire system. I just want to close with a final slide. So I just want to touch on these key points to bring together everything that's been discussed and just sum up the essence of the discussion. So right at the beginning, we talked about the difference between occupational safety and process safety. It's really important to understand that personal safety and occupational health and safety doesn't control process safety risk. It just inherently doesn't have the right approach. And whilst it's very much related and it can go a long way to managing common hazards, it really isn't going to deliver some of these detailed technical aspects that are needed to fully manage your process safety risk. The definition of process safety drives the operational scope and the entire business focus. So starting with hazardous chemicals and just viewing loss of containment, that's a very useful way to look at process safety risk management, but it may be too limited depending on what's happening in your business and your operations. So if you've got process hazards that are fatal and you've got operations that have loss of containment and loss of control risk, it is worth looking at expanding that definition and how that fits. And also the discussion earlier around water. So drinking water quality management is quite critical. However, process safety can support and assist the management of water quality and safe water as well. The water industry has numerous hazards with fatal potential. We've just looked at the different technologies and how those technologies will emerge over time to create potentially more hazards. And those hazards are both process and chemical. They're not just around hazardous chemicals. The hazardous chemical approach for process safety in the water industry is likely too limited based upon the nature of the operations that we have and the types of hazards that we have in our facilities. So it's an important thing to consider. It's a great starting point. However, it goes beyond just the hazardous chemicals. The absence of major hazard facility requirements does not mean that you do not have major incident risk within your facility. Now, MHF and safety case legislation focuses on controlling major hazards and preventing major incidents. Major incidents can be defined either as having on-site or off-site impacts, and generally there's a focus on off-site impacts with this particular safety case view. But it's important to recognise that all of us have the obligation under the Work Health Safety Act and the legislation to reduce risk or eliminate risk or reduce risk to FARP. Process safety supports that assessment and the work that's needed to be done to arrive at a SFARP determination, which is really critical. There's a potential over time as we evolve the industry more towards waste to energy, that risk increases. So we need to be really mindful of the technologies that we bring in and have a good view on upfront early design and hazard elimination, and if not possible, really, really robust engineering controls and operating and maintenance practices to manage that hazard through its life cycle. And finally, what can't be measured can't be managed. As I've said through the presentation, you really have to focus on understanding your incidents and focusing on what's critical in order to do that. That wraps up my presentation. Thank you.
Thanks, Jamie, for your presentation. Well, now it's our audience's turn to get involved. So please ask Jamie your questions via the chat box. And a big thank you to everyone who submitted questions while registering for today. What I might do to kick off is I might start with one of the questions that we received from registration. And this one came through from Lucas from Queensland. And the question was, what PSM management tool, enterprise software, is used by industry to manage PSM critical maintenance and inspections, Jamie?
Okay, thank you for the question, Lucas. I can talk a little bit about what we've done and what we're continuing to do. In that space, from the bow tie assessments, we've got a computerized maintenance management system known as Ellipse. And we've gone into Ellipse and put safety critical element flags on equipment associated with critical barriers, and then built Power BI dashboards that can track maintenance completion rates on critical equipment. So that's one important step that we've taken in the maintenance and inspection space. The other thing we're looking at and we've started on is training people on safety critical activities for certain maintenance tasks that are related to the integrity of safety critical barriers. But the other stuff that we have looked at and continue to look at is the use of our enterprise GRC, or governance risk compliance system, for management of change. And we're using Bowtie XP software, and we're integrating those two together to try and complete that picture. And you won't get, I don't think, it's difficult to get one system. There's going to be a number of systems, a number of pieces of enterprise software that have to come together to do that work. And with where we are at, we found that registers have to sit outside of some of those systems and be brought in and integrated through databases and things like Power BI as well. So hopefully that answers your question, Lucas.
Thanks, Jamie. The next questions come through from a Raj from South Australia. Two parts to the question, so I'll start with the first one. What are the main challenges in implementing process safety management in water utilities, considering their differences from chemical manufacturing? And then the next one was, how can water utilities tailor existing safety frameworks to address the specific risks and operational safety concerns they face?
Yeah, great question. I think to answer the first part of that, it's around applying it appropriately only where needed. So this can be quite onerous and it's a lot of work. So I think it's really important to get the definition and the scoping correct. And I talked about that earlier in the presentation around what it means, how that drives the assessment, and what that's going to mean in terms of resourcing and where you're going to focus, and really focusing on low frequency, high consequence events. So I think, the main challenges, I think, if you think about the framework, the first thing that has to happen is there has to be commitment to actually do the work. And if that's not agreed, or if that's something that the business doesn't want to do, it's going to be very difficult to do any of this work at all. But assuming you can get past that and you can get an agreement that it is the right thing to do and it's needed in the business, I think one of the biggest challenges is defining what it is and what it isn't, putting a scope on it, some proper boundaries on it, and then starting off with the hazard analysis and the risk assessment. With respect to your second part of the question with frameworks, I touched on a little bit sort of towards the end. I think it's really important that you look at your health and safety management system, your asset management system, and ISO 31000, and look at how you can bring them together. And something that we're doing at the moment is developing an internal process safety standard that has all the performance expectations to manage process safety, and then looking for evidence in our management systems of where that is or isn't being done from a perspective of an auditing tool. So I think you need to leverage your existing systems and make the most of them. But in respect to challenges, they're the technical aspects, but cultural is a big one. We need people to understand hazards and understand their role in controlling them, and be trained, which can be a pretty big job across the organisation as well.
Yeah, thanks for touching on that. That was actually one of the other questions was around cultural challenges within a water utility. What I might do is pull in, Jamie, a couple of the live questions for you. So Neil Harry, hi Neil, watching live today, had a question. Do we need LOPA? And I hope I've pronounced that correctly, or should it be LOPA? I'm not quite sure.
It's LOPA, yep.
LOPA.
Definitely. So it's not something we've done a lot of, and I think it's probably more limited in water industry than it would be in others. But if you want to quantify risk, definitely it's a great tool to do semi-quantitative risk assessments. We have used it to identify risk gaps and determine if we need safety instrumented functions on a boiler, and it's been effective. We've ended up upgrading some of the instrumented systems there to higher integrity systems from that. I think if you start with bow tie and you know what your controls are, and you go through and you look at what barriers are independent, truly independent, and you get a feel for the depth of controls that you've got, you can then start to look at LOPA from there. You can go from HAZOP directly into LOPA and form up a scenario that way. But I think the need for LOPA is really driven around the need to quantify and understand the level of risk, which requires a whole heap of other things like risk tolerability and acceptance criteria, because you need to LOPA to a target. The methodology is not really that well understood in our industry, so you need expert advice from people generally in oil and gas that have done a lot of this stuff. So you make sure that you approach it correctly. The technique's already pretty conservative, and if you go overly conservative, you can get yourself into a lot of trouble and find yourself needing to upgrade systems to very high integrity, which is very costly. So there's a lot to consider in doing that. I think in our industry we should be fairly cautious with that.
Thanks, Jamie. I've got another question. So, Kaj is watching live, and the question was: does process safety cover reliability of operations? Note that disrupted plant operations can affect public indirectly.
Yes, I think where I think that's particularly relevant is if you look at the BOTO diagram and you look at each barrier. I haven't really talked today much about risk assessment. It was all around hazard analysis. But in terms of risk assessment, if you do a qualitative risk assessment on the bow tie, one thing you definitely need to understand is what's the effectiveness of each of the controls or each of the barriers. And when you start to look into the effectiveness of the barrier, you're looking at the performance and the function of all of the respective pieces of equipment in there. So there's a need to understand the functional requirements and the reliability of each of those components to say that that barrier is performing the way that it should and that it's effective. Once it's effective, you can then move through to your risk assessment and say, I'm fairly confident that my risk rating is reflective of what's actually happening because I understand the reliability of my barriers. I think I'm taking a guess that that was your angle. If you're talking about reliability of operations, there's a human factors element too, where people need to be trained to respond consistently over time as well. So there's a procedural element. So if you've got an alarm driven from an instrument and you need people to respond to that and do it consistently, it needs to be proceduralized and they need to be trained. So you can have some standard, you can have confidence that the standard that's applied to that is upheld. and maintained over time.
Thank you. I'm just coming up to, I had a question and I lost it. Now I've got it back. Jamie, there was a question which came through live. I think Williamson is his name. Can you provide examples of actual scenarios on risk management in wastewater plants that the HAZOP is implemented?
Yeah, okay. So in HAZOP, we tend to focus on the deviation, so the cause of the incident. We've got screening tools that help us identify the consequence. We generally don't do a risk assessment in the HAZOP. But a couple that I can think of from memory are loss of containment due to overpressure of steam. We've got a steam boiler. We've had one risk I can remember. We've had the possibility for a CO accumulation and congestion in the firebox of a steam boiler. So we've got an economizer with controls that detect that. Otherwise, we can have a furnace explosion on our steam boiler. There's other examples, kind of a little bit simpler, where with anaerobic digestion, if you don't control the temperature and the loading rates, you can have too much gas yield, and then you can have overpressure events and uncontrolled venting through PSVs off the top of your anaerobic digesters. Yeah, so in terms of a loss of containment, there are a couple that come to mind, and then there's others around cogeneration, where you can have arc potential, and you can have a loss of containment from gas, whether you're using biogas or natural gas, that comes up quite often as well. So hopefully that answers your question.
Thanks, Jamie. Look, I think we're getting through quite a lot of questions and we've just about run out of time. I will just ask one final question, which came through from Sujith, and he was interested to understand if a safety critical alarm system and human response has been considered as a barrier, and if yes, is there a recommendation to adapt a functional safety lifecycle management approach for the design, build, operate considered as a recommended practice?
Yes, so on our bow tie diagrams, we have considered barriers where an operator response is required to fully execute the safety function. We are still looking at whether or not that would be considered an independent barrier. It's likely it's not, because it's going back to the same operator, and a lot of alarms are going back to the same operator. So potentially not. In terms of the functional safety side of it, if I understand your question correctly, if we looked at the bow tie diagram and we had a line where there was a lot of instrumented controls with operator reliance, we might actually decide to replace or upgrade some of those controls so they're fully instrumented and automated, so we don't have the operator needing to respond as a safeguard to minimize the risk. But where we've got SIL-rated devices, we have functional safety plans to manage them from the project creation through to lifecycle management and O&M. And we don't have a lot of those, thankfully, and I can't see a whole lot of them being needed in our industry, generally based upon the processes that we've got. But I think it's a really important question around whether or not, if you've got human action needed, whether or not that barrier can be considered independent in a functional safety sense, and what to do about it. So it's something we're still looking at and we continue to look at. But for the moment, yes, we do put them on the bow tie because they are a valid control. But when we get into using them in LOPA and looking at independence, we're treating them with caution, and we're saying at the moment they're probably not truly independent controls.
Excellent. Thank you. Great answer. And I hate to say it, but that's all the time that we have for today. So a huge thanks to you, Jamie, for your time and input in today's session. I can see everyone, sending through their thanks and how much they've enjoyed the session. So a big thank you to you. I would also like to thank Engineers Australia's industry partner, Urban Utilities, for their support today. And if I could please ask if you could complete the short feedback form, which is linked in the description box below. As you all know, this feedback helps us to improve and plan future sessions for you, our audience. So finally, thank you again for joining us, and we hope to see you at our next Industry Partners event. Good afternoon.